Oh man, are you trying to figure out a wireless router slash wireless access point solution in 2025? And the Netgear RS700S Wi-Fi 7 access point brought you here? I'm so sorry. It's turned into a huge mess. And this is not even the first video that I've done on the RS700S, but this is the full review of the RS700S against a backdrop of the ROG Strix BE18000 and an ingenious, what was the ingenious? It was the ECW 536. So we got some comparisons here and some Wi-Fi 7 and that sort of thing. It's going to be a lot of fun. All right, let's get started. Okay, so this is an access point that has 10 gigabit ports. That is the most attractive thing about this. The second most attractive thing about this was the Netgear successfully convinced the U.S. State Department, was it the State Department? The current U.S. administration, that Netgear should be the only router that's not on an import ban list, which is insane. I did another video on that, and you should look at that, because it's kind of hypocritical. Under the hood, Netgear stuff runs Linux, and we'll talk about that in the security section. But mostly this video is focused on the actual performance and everything else of this, which actually turned out to be quite good in most scenarios. Yeah. So I was surprised too, but you know, call it like it is, right? All right. So this is Wi-Fi 7. The really amazing thing with Wi-Fi 7 is that there's a lot of optional features in Wi-Fi 7, and optional features is where marketing goes to party. And they certainly have here. Wi-Fi 7, 3 frequency bands, ideally. 2.4, that's the old one. It's junky. It's filled with crap. It doesn't work all that good. 5 gigahertz and 6 gigahertz. Those 3 bands. Most clients, most good Wi-Fi 7 client devices have a radio in them that can do 2 frequencies at once. This actually will give you a really solid, reliable connection, because when there's transient interference or anything else like that, theoretically, your client could send data over one or the other channel really quickly. There is a part of that where it checks to see if the channel's clear before it sends, but sometimes the timing of that is not perfect and 2 things speak at once, and then they have to randomly decide. It's a random amount of time before they retry, but mostly. Not all clients do that. Not all clients actually speak at the same time on 2 different frequencies. Sometimes they'll mainly use 1 frequency, and they'll use the other radio to just keep an eye on availability of the frequencies, and then they'll send a thing that says, okay, we're switching frequencies. It doesn't actually use both frequencies at the same time, but it'll really quickly switch between frequencies, which is handy. And 2.4 gigahertz sometimes will have long haul. 6 gigahertz doesn't really work super great through walls, especially if you have lath and plaster walls, that sort of thing. I should also explain a little bit more about our testing methodology and protocol, because I'm still working on that. And there is a full write-up of this on the Level 1 Text forum. I have to say that a few times. I get sort of mixed messages, because sometimes everybody wants a quick and dirty video that's like, here's the stuff, good luck. There's a write-up on the forum that has information about why I came to those conclusions. And then other times, I will do both in the same video, which of course ends up being a lot longer. And people complain either way. So I don't know. We're going to do a little bit of both in this video. We'll just see how it goes. I'm trying to figure this out a little bit, because it's been a while since I've done these kinds of reviews. And I think it's more important than ever to do these in the context of, OMG, what is the government doing? Oh, they have lost their minds. The router ban doesn't make any logical sense for anybody that knows anything about technology, because everything consumer grade is made out of paper mache and cardboard, including Netgear. Sorry, let's talk about the performance. Okay, raw throughput tested on 6 gigahertz with a 320 megahertz channel width. The wider the channel, the more data you can pack into that channel. But if there's a lot of people around you that also have Wi-Fi 7, you're going to have a bad time, because at the periphery of that channel, or even if there's multiple access points using the same channel, there's going to be overlap, and you're not going to be able to use the channel while somebody else is using the channel. So 160 megahertz or 80 megahertz, those are options for how wide the channel is. The wider the channel, the fewer channels you have in that 6 gigahertz band. And so if you don't have a lot of neighbors, or you don't have neighbors that have Wi-Fi 7, you can use a really wide channel. But in your particular situation where you are, it might actually make more sense to use 160 megahertz or 80 megahertz, a more narrow channel. Now, the radio also has a faster signaling rate, so you still get higher throughput than you would on, say, Wi-Fi 6. Okay, that's not completely true in all scenarios, but generally that's true. And remember what I said about optional specifications? Even the labeling on the box, Wi-Fi 7, Wi-Fi 7 certified. Wi-Fi 7 certified is probably actually the best because the Wi-Fi consortium has like looked at this. You can look up on the web page for Wi-Fi certified and see what features from Wi-Fi are actually implemented. That MLO, the multi-link operation on this thing, not actually implemented. And yet it has some of the fastest transfer speeds that we've seen from any Wi-Fi 7 devices, even outside the other two that I tested and included for comparison in the review. So anyway, throughput, TCP, client server, one stream going on the thing. This was also tested in a Faraday cage. Everybody, let's take a look at Basement Cat. It's a long story, but I have a Faraday cage within a Faraday cage. An RF chamber within an RF chamber. Long story. 2.3 gigabit. If we have two streams simultaneously, client to server, we're getting an aggregate of 2.8 gigabit. If we do server to client with one stream, we're getting 3.1 gigabit. This is important because sometimes from your laptop to something on the internet is weirdly slow through your router or through your access point. This, the GSBE 18000, when it is in router mode, for some reason, when you send from a laptop to the internet, it is weirdly slow. It's not glacial, but we're talking like 300-400 megabit, not gigabit, not multi-gigabit. It's weird. It's the only one that does that. So we got a little graph of our forward UDP loading sweep, TCP and UDP loading sweep, and UDP performance. UDP doesn't have acknowledgements. You just send the data and hope it gets there. And the performance of this is a little slower. This is also on WPA3 SAE. And this performance does change. Like you can use WPA2, a lesser encryption, and the geometry of your performance here is different. UDP generally is better on WPA2, and you don't want to use WPA1 because it's not secure, and you don't want to use no encryption. No encryption is actually the fastest in some scenarios when we're talking about this. But generally, like those are not things that they have, like that should not even be part of the review. WPA3 is. Now the 3.5 gigabit TCP reverse is sending from the client to the access point. And that is the fastest speed that we got on any of this gear. That is impressively fast, 3.5 gigabit. Remember, we have 10 gig LAN ports. I'll come back to that because you can also use this for wired connections. And you'd expect it to be able to route 10 gig from the LAN to the internet, but it can't. Not really. I mean, it can't. Mostly it can't. It can't in real world scenarios. It can in test scenarios, but we'll talk about that. So for a three-way comparison, I've got a little comparison here. TCP2X forward, TCP2X reverse. That's what I mean, forward and reverse. Who's doing the sending, who's doing the receiving. The other thing that I want to look at here is latency. What is your P99 latency? When this link is fully loaded, does your latency double? Does it go to 100 milliseconds? Does it go to like 500 milliseconds? Buffer bloat. There's this terrible thing called buffer bloat that was discovered and dealt with by Dave Tott. I knew Dave Tott before he passed away. And he taught me some things, and that was a lot of fun. Some of the access points here do have a little bit of buffer bloat, but generally the worst P99 load on all three of these access points were right in line. It's about 20 to 30 milliseconds, give or take. Not too bad. For the MLO support, this is like advertised by the access point. It doesn't really have much of anything to do with the client. It's something the access point advertises. And this changed a little bit as I was working on this. Ingenious actually issued a firmware update like 3 weeks ago, and their MLO support for EMLSR improved for 2 links. And that's working on the ECW 536. I've got a full review of that coming. There's some other stuff we got to talk about there. And the Asus BE 18000 advertises multi-link, but it really just lets you switch between multi-link links quickly. MLO support was not detected at all on the Netgear, and yet it was absurdly fast when it's just isolated on the Wi-Fi 7 bandwidth. And I'm so sorry that this is something you have to look at and understand when it's like, can I just buy the Wi-Fi 7 thing and trust that it's going to work correctly? And I would like that too, but that's not the world we live in. The Netgear showed about 0.26% packet loss for UDP single stream and 0.07% on multi-stream, which is quite good. I think anything less than 1% is reasonable. However, the other two access points didn't lose any packet. Well, it's like 0.01%. The Netgear's idle latency, like when the link is not saturated, is also a bit higher. Don't know why that is. I did not enable any other optional features. So when you get one of these and you unpack it out of the box, it really wants you to use a mobile app. The mobile app permissions are kind of suspect. And if you know enough to go to your router's, like the 192.168 internal IP address to configure it, as you've done, for like 7 or 8 generations. I know my audience, there's a lot of you that are technical, and it's like a lot of you know how to configure your router, not through an app, but just, doing it through a web browser. There's dark patterns in what you experience in the web browser from your Netgear to get you to set up the app. And the app will work cloud connected or anything else like that. We know from the security analysis, I got to plug the security analysis video again. If you really want to go down the rabbit hole, you should check the security analysis. Some dark patterns there too. Not super secure. There's a secret packet you can send to enable an SSH connection, which is not documented. And a lot of the software is not as up to date as it could be, which is super disappointing given Netgear's lamentations to the US government again, router ban. Super, super disappointing. But the mobile app for control of this, I am not that's not an automatic terrible thing. Like, I am not completely against that. But if the mobile app is running all the time and doing stuff in the background and reporting telemetry, I have a problem with that. That's not good. I'm not sure if the Netgear application is doing that, but when I was using, a scope to see what the app was doing on the internet, it really should mostly just be communicating with Amazon's Internet of Things service. Like how they built it was using Amazon. Amazon has some Internet of Things services and telemetry and that kind of stuff. And so I was not expecting this thing to be as chatty as it was in terms of the application. That's also maybe a risk because, like, what if something happens to Amazon's infrastructure? Does that automatically compromise your router? Because the bad guys want to live on your router so that they're just there forever. I don't know, but that's not really within the scope of this video. I also didn't like that there are freemium features on here. Like, there are subscription-based things to do with parental controls and DNS and some antivirus malware filtering. Those things are always running in the background on this, even when you're not subscribed to those. And that may be why the floor latency is not as good as it could be on this. I'm not really sure. I would have to go even more down the red team hacking thing to disable those services and figure out if the performance is there. And nobody is actually going to do that. Like, if you're going to do that, really, this thing should just be running OpenWRT firmware. You should just blow away all the Netgear firmware and forget about it, which is not a thing you can do currently, but maybe in the future, the not too distant future. That would actually be a better world for you, not using Netgear's firmware on this otherwise fairly reasonable hardware. So wireless latency for gamers. And this is really interesting. So forward UDP sweep, and if you look at around 1.5 gigabit, are ingenious spikes up to about 80 milliseconds. I included this graph in this review, which is actually fixed in a new firmware. This is an artifact of testing, more or less, but this is also a real world thing you can encounter. So understand what's happening here. Why would the latency go to 80 milliseconds when we go to 2.5 gigabits and it comes back down under 20 milliseconds in a Faraday cage? The reason is to do with power save, and the reason is to do with frequency hopping. At that amount of bandwidth, the radio can kind of go to sleep and wake up, or use low power, or switch frequencies, or something like that. And this is a combination of client and server. This is not just the access point, but the right combination. It's like the perfect storm of variables. This is kind of the perfect storm of variables. And this is something that's really hard to get right in the firmware of your access point. When the link is not fully loaded, you can see weird latency spikes. This is really bad for MOBAs and things like that. Like if your ping time is 30 or 35 or 40, and then all of a sudden it's 150, which is what you would get if this happened real world, then, it's like, oh, you're rubber banding, or, oh, something went wrong inside the game. You don't want an access point to do that. Netgear held up pretty well, even when it was fully loaded. This is also another dimension of testing that I want to do a little differently. You see, I got mini PCs. Like, We use this mini PC QB-NUC from MSI. This has the Intel BE200 Wi-Fi 7 NIC in it. And, it doesn't have any external antennas or anything like that. But I love putting a bunch of these machines in that room and having them doing a test to the test server at, say, 500 megabit. 1, 2, 3, 4, 5, 6, 7, 8 clients. I know the radios can operate at 2.5 gigabit, but does the radio do a good enough job having each of the clients juggle their streams so that one of them doesn't experience terrible latency, and it also uses the available bandwidth? I've not done enough testing with 8 clients. The most clients that we did for this testing was 4 Wi-Fi 7 clients, 4 different clients, to see what we had in terms of aggregate bandwidth and all the other kind of stuff. We would expect the available bandwidth to fall off exponentially as more clients enter the medium. And I'm seeing some testing artifacts from doing that, so I'm not ready to include that kind of testing. But I think real world, if somebody is streaming Netflix and you're trying to play a MOBA, for this class of access point, it's not going to significantly impact your ping. That may not be true if there's 3 or 4 people in your house trying to watch Netflix while you're trying to have a good MOBA experience. But I'm going to have to do that kind of testing later. But it is really super interesting. It's a whole rabbit hole. If you'd like to learn more about that, there's a little bit more of a write-up on that in the actual benchmark for gamers and game latency and like what that actually looks like. It doesn't really speak to the multi-client aspect of it, where you got a whole bunch of clients that are trying to use that 320 megahertz channel width. That is a different conversation, but it does give you an idea of like, hey, what do I need to think about in those terms? Like, what's going on? Why is it like this? There you go. The other thing I would say is, remember, this is also in a Faraday cage, which is not real world testing. If you're in an apartment building and there are other people that have Wi-Fi 7 and they're on the same 320 megahertz channel as you, something they're doing could interfere with your ability and wreck your pings and do all that sort of stuff. So sometimes it's useful to run a program that plots ping times in the background, and you're sending 3 or 4 pings a second to something on your local network. Don't send it to the internet. And then plotting what your latency looks like over time as you play a game to troubleshoot wireless problems. Of course, you could always just wire in. Wiring in is fine for games and a great way to deal with it. Approaching that kind of a problem where you got a lot of clients is also part of the load sweep, latency versus offered loads, going from 100 megabit test to 2.5 gigabit. Can we achieve that with a 2.5 gigabit client? And what does that do to our latency? That's what we did there. And you can see there's a little difference there between UDP and TCP from the earlier test and 2 streams at once in both forward and reverse directions. Now, Wi-Fi 7, a big part of that is MLO. And so I want to do super deep MLO testing. Netgear was super disappointing here because it's Wi-Fi 7, optional feature, marketing goes to party, no MLO. Now, bottom line, the wired ports on this, 10 gigabit. They can sustain 10 gigabit forward and reverse line speed. It's amazing, but only for about 8 minutes. And then thermal throttling seems to kick in, and then we're running at about 4 or 5 gigabit. This is 10 gigabit from the LAN side to the WAN side and from the WAN side to the LAN side. It's 10 gigabit, but you're going to be wanting to use this with like a 10 gig switch. It doesn't even really make sense, the 10 gig part of it, because one of the ports is 10 gig on the LAN side. The others are 2.5. So you could put your server in 10 gigabit, and then you could have multiple 2.5 gig clients connecting to your 2.5 and then 5 and then 10, the other ports in aggregate to your 10 gigabit server. But that worst case scenario is not really sustainable for LAN to LAN traffic. And if you connect a 10 gigabit switch to your Nighthawk Wi-Fi 7, all of the traffic will stay local to the switch. So if you have a 10 gig client PC and a 10 gig server and you're moving files back and forth, it's not even going to hit the 10 gig port on your Netgear. Do you have a 10 gig internet connection and you want to be able to offer 3.5 gigabit and beyond to your wireless clients without interfering with your wired clients? That is the only scenario where the 10 gig interface on this makes sense. But then it doesn't really make sense to have the 10 gig, only the one 10 gig port on the LAN side, unless that's just an uplink to another 10 gig switch. And even if you had 10 gigabit of throughput to this thing, it's not like the physical hardware seems to have problems with the 10 gigabit. And then if you are using those optional features like client filtering and the antivirus and that kind of thing, and it's actually examining things, this little processor in this thing is going to be overwhelmed immediately. So that's just something they put on the box. Is like, oh, 19 gigabit Wi-Fi speed, faster Wi-Fi on more devices. And it's like, it's really a function of the number of radios in the device. And also it's like, oh, 10 gig plus 4 times 1 gig. They couldn't even do 2.5 gig. Like, come on. At least give me 2.5 gig on the other ports. It would have been an extra 75 cents. Oh, also footnote, it has USB. You can use USB storage. Don't use USB storage because it advertises SMB-V1 support, and at the danger of accidentally creating a 0-day, don't use the storage. You don't want to use the storage. You don't want to use it as a NAS. Trust me. Yeah, that's pretty much it for the RS700S. It really does have the goods. Like, it's like 3.5 gigabit wirelessly to a single BE200 client, and 2 BE200 clients, you can actually get even beyond that. Like, you can get 2.5 gigabit on multiple clients, which is amazing. But everything else really leaves a lot to be desired, and I don't like the app, and I really don't like the way that Netgear is. It's like, oh, we're when their laundry list of software is horribly insecure. Check out that other video. Unbundled level 1 has been a quick look at the RS700S. This is probably a better overall normie router. This is the best access point ever because this is really more like prosumer commercial, and this is like prosumer enthusiast, and this is like trying to be enthusiast, but I mean, it is what it is. There are aspects of it that aren't bad, but check out the written review if anything is still ambiguous or weird, or you didn't like my rambling. The write-up is an attempt to be more succinct, but this gives you some color and context. So about all this level 1, if you have any questions or I miss anything, there's the forum. Come participate. All right, I'm signing out. I'll see you there.